All right.
All right, we good?
Decentralize the recordings.
Yeah, well, after last week, I thought, somebody else needs to record this now.
Yeah.
No idea how I messed that up. But anyway, all right.
I really liked the summary you wrote last week.
Yeah.
Well,
even with the video, it would have been nice.
All right. Well, I might do the same thing. But so in this week's Zoom, we're probably going to rattle through pretty quickly what the dev team's been up to, and I'm just going to cherry pick some of the more important things that have been worked on because we want to give some time to Colin to do a demo of some of the APIs in action. So hopefully we want to leave enough time for that. So I'm just going to jump right in and just so everyone knows, prior to this meeting, this is why we're late. So apologies for being late this week. We have a tech call amongst all the developers prior to this meeting where we round robin through all the developers and everyone gives an update on what they've been working on, and then I put it into a big long list, and then I try and relay that list to you in some kind of sensible order. So I'll refer to my notes and try to pick out the more important things. Let's start with the changes to SIG chains, because I think that those are quite important. So Colin's introduced Argon 2 as a proof of work mechanism that we are adding to the hashing of SIG chains. Is that the right way to describe that, Colin?
Just basically call it like key generation and username generation.
Fine.
Yeah.
So what that does for us, first of all, it adds some security to the SIG chains because it stops dictionary attacks, so you can't brute force
Slows them down.
Sure, it slows them down,
Yeah.
which is a feature, not a bug, because the other side of it is it slows them down, and that means that we do have a limitation on the number of transactions that can be produced per second, I guess, on a SIG chain, and that's limited by hardware. So as I say, we're using Argon 2, which has parameters for how much memory hardness it has and how much CPU it requires. I think that's right. There's those two parameters. Is that right, Colin?
Yeah, and it basically levels the playing field across every single device. So a field programmable gate array or an application-specific integrated circuit, otherwise known as FPGA or ASIC, or even a GPU farm, have no advantage over a CPU, because what it basically does is, being memory hard, it basically puts the computational time requirements on the memory latency. So even with an ASIC and a bunch of DRAM, you'd still have an incredible amount of computation time required. Plus, you can't parallelize it other than the amount of memory you require per hash. So what this basically means is somebody with a huge word list and a GPU farm or an ASIC farm won't be able to actually try any more candidates than somebody with a simple CPU. So it definitely helps significantly in preventing the brute forcing of any passwords. And it also acts as a secondary rate limiter for your personal transactions per user, which is something we closed or disclosed or talking about last week about how we were deciding about how do we rate limit it. So it basically works as a form of proof of work, so that you can't brute force usernames or you can't brute force passwords more than, I think we have it set for about 3 times a second. So, I mean, when you start talking about, 10 million, 100 million passwords that you're trying to crack, or a huge list, which usually end up being half a billions that you'd have to run, basically divide that by 3, and that's how many seconds it would take to actually try to brute force. So you basically make the time requirement for trying to hack somebody's account or hack their SIG chain from, days to years to decades even. I mean, and we can control those parameters directly by the memory hardness and the actual computational requirements, which adds a lot more security. So we'll allow you to parameterize that too for the more advanced users. Come more mainnet if you're super paranoid and you want to make your SIG chain take 5 seconds to generate a transaction, you can. And it's going to take, and then that's another secret parameter too, because nobody will know the complexity you use for how many iterations you require, how much RAM you require. So as long as you want to remember those types of things, they'd just be brute forcing passwords based on the requirement right now of 11. But if you customize it yourself and change it, as long as you remember it, you'll be able to generate your sig chain, and you'll be able to increase the time, and you add another dimension of brute force protection. So it's a really nice, extensible, changeable routine, and it won the password hashing competition. So it replaces things like bcrypt, scrypt, and I think it PKS, whatever. I can't remember the exact name. As you know, script, scrypt, that's what's used in Litecoin mining. That's a memory hard algorithm that was designed for password hashing. But as we've seen, scrypt can still be used on an ASIC. It's not up to full parameters. Bcrypt is another one that's been used. That's on OpenBSD systems. That's been around for a long time. But this is kind of like a next iteration of password hashing. And we found it really comparable because we can basically customize every single aspect of that to just increase security, 100-fold. So I think that's been something really exciting. Sorry, I didn't mean to kind of steal the role from you there, Paul, but I figured I'd share some of the fun things that we've been working on with that. So that's running in testnet right now. So you'll see the effects of it when I share my screen and show generating transactions, that it does take about 1 second to generate the transaction, which is good because that means it takes around 1 second for somebody else to try to fake a password or try to brute force your account.
Yeah, as you mentioned, the secondary benefit of that is that we're stopping transaction spam. So people can't spam transactions on a sig chain because
it doesn't matter if you've got a GPU farm. That's what's so cool about it is it's just level across every single device. So everybody's pretty much put on an equal playing field there as far as requirement, where your regular computer all the way up to an ASIC will perform the same speed.
Yep. Okay, so moving on from that, there's been some work done on hybrid mode. For running our blockchain in hybrid mode. And just for those who don't know what that is, we've already mentioned private mode, which is where people can run a private blockchain. They can generate blocks very quickly. There's no requirement to have miners on a private blockchain. I think that's correct, right, Colin?
Well, there's 3 versions. Yeah, there's this like full permissioned, which is you configure, say this is the only sig chain that can produce blocks. Then there's semi-permissioned, which is, okay, well, these specific sig chains that are, let's say, delegated or elected can be multiple validators. And then there's the open private network, or the more like semi-permissioned that I like to say, which is a proof of stake one, where you issue tokens on this private network, and those tokens become proof of stake tokens that you can distribute out, which is probably the way that most of it are going to start to unfold. But the private mode really, right now, is just mainly for a lot of testing purposes for high transaction volume. That's where you saw my post-processing speeds of 50,000. That was just in a simple private mode, creating the transactions and doing all the post-processing on it. But that's basically the hybrid mode, is just where you have your blockchain and then you have your private blockchain, and then they inject data into that.
Now you're stealing what I'm saying. That's what I was about to say.
So
I was going to explain private mode, which is very much geared towards sort of enterprise customers who are enterprise implementations who are going to want private mode. And then the hybrid mode is where we can take output from that private mode and those hashes and put them into our public blockchain. So a private blockchain can benefit from the security aspects of having the public blockchain as well. And that hybrid mode is a really big selling point for Nexus when we're looking at large scale, enterprise scale implementations, because they almost certainly are going to want to be using a private chain, but still benefiting from the security of the public blockchain. So where are we at with development on the hybrid mode?
Basically, we just need to finalize some of our testing stuff. All the architecture is built in there, so it's just simply deploying another LLP for the hybrid network, and then making sure you're synced up on your public network that you're synchronizing to, and then putting in a simple rule to say, well, this block, when you're syncing on the hybrid network, is only valid if it's in the proof of work of this other block, which we just do a pointer. So by next week, we'll probably be able to give a little more. I just kind of started the last day or two on hybrid mode, which was kind of like there's a series of prerequisites to get just a hybrid mode running on a test net. So I'll be able to report back a little bit later next week, I think, next call, how that development's going. Mainly just been focused on public network development for this last week.
Okay. All right, I'll just rattle through some of the other stuff that was worked on this week. I think probably one of the more important ones is there is some work being done on the legacy wallet. There's some speed problems we're having, some performance problems we're having with the legacy wallet on Windows. I think that's leading us down the track of needing to change the serialization format of our legacy wallet, if I've understood that right. And if we do that, it means that we're going to need to find a way to migrate existing wallet.dats to that new serialization format. So we're looking into that right now and figuring out how we're going to offer that migration path. And then I just need to mute some people. Let me, there you go. So that's something that's coming up. There has been some work done on staking, still on legacy staking. I think something that you guys might be interested in is we are doing some work on a universal miner, which incorporates the best pieces of the hash and prime miners that are out there to produce one piece of software that can be used on both prime and hash channels, both with a GPU and CPU. I know that CPU mining is not really profitable or anything right now, but it is really useful for testing, definitely on the testnet. So that's something that's being worked on. And the sort of corollary to that is that we also need to update our pool server software to enable it for the hash channel. At the moment, it only supports the prime channel, and make that available publicly as well, so we can get more prime and hash pools up and running. We've started down that track, but it's not something we want to spend too much time on at the moment, because obviously we need to get Tritium out of the door. But it's the reason we're doing it is that we need to be able to do testing internally quickly and easily across hash and prime channels, and also test out our mining LLP. So the wallet side of talking to all these miners. So it's much easier to do that if we have a universal framework, a universal miner that we can run up and do our testing on. So that's why there's been some time invested in that. On the GUI side of things, probably the most energy at the moment is being put into resolving all the bug reports that are coming out of the beta testing. So the guys have predominantly been working on that. And I've just had a message pop up saying that we're going to run out of time because we only have a 40-minute limit. Did you guys know we had that limit? Colin, I'm looking at you here.
I have a Zoom at Nexus.io you can use from now on if you want. It's paid and it allows 100 participants. And I think this one probably only allows 20 participants. So if you want to lift that limit, we should probably start using that link rather than this one.
Okay, fair enough. I don't have a participant limit. I've got a time limit of 40 minutes, which means I've got 9 minutes left. So I'll tell you what we'll do.
You have 9 minutes left?
Yeah, 9 minutes and 13 seconds left.
Wow. Okay, well, I should jump into the demo then?
Yeah, well, I was wondering whether we stop and start, whether can we end the meeting and start a new one, and then do a second recording from there.
Yeah, if we want, or we can put something. It takes a little bit to type the stuff in, but I guess maybe we just open it up, just finish up, and then open for questions, and then we may be able to start a new one. I don't know if it throttles it and says, "Okay, well, you just stopped and started a new one again."
Okay, well, let's do that, because we can always revert back to Telegram and Slack to post a new URL for another meeting if we need to. So, does anyone have any questions on things we have talked about so far, or anything else for the team before we launch into a demo?
Should be able to pull a demonstration in about 8 minutes as long as we don't have too many questions.
Go for it. Jump right in.
Okay, let's share the screen. All right, so you guys can probably see Zoom, right?
Yep.
Okay, we can see this now. Yep, okay. I'm going to assume that we can. I'm going to move this over here. So this right here, we have our basic testnet going on. I've got just kind of a localized one, testnet 8, producing blocks. So here you can see some of the assets commands. So this is obviously an asset history command, as you see. It transferred from this Genesis to this Genesis. This was just a simple asset. Let's see, name equals my asset. So this one's just a simple one showing, okay, well, here's the metadata that describes the assets. So, you know, these APIs are more lower level APIs, so we don't have any schema or format specifically specified. So these are just able to create at will. So let's go up here. This kind of shows my long history of commands. I guess we start. So this is my account. Now I'm going to say, let's grab my session ID, because since I'm logged in, I have to track it by this specific session. So this is my Viz, or actually this is my Colin account, and then the other one is Viz. So if we go into the tokens, this is the one I really kind of wanted to show you guys a little bit more of. Everything's addressable by name, which is pretty cool. So what we do is we put our session ID in here, pin number 1, 2, 3, 4, type, it's going to be a token, and then we're going to say name equals token 333. And what's cool about this is going to resolve into a register address. So this is addressable if you know its name. Otherwise, at the network, it's anonymous. So same with the username as well. There's Genesis ID. I believe this one is Colin and this one is Viz. You don't know this is Viz, and it takes you a second to generate my Genesis ID, so you can't really brute force too quickly. So that's another really cool feature, is you actually have accounts that are addressable. So I'm going to create this. Identifier is the token name specifically. This would be just the identifier. So identifier 0 is obviously Nexus. And then supply, let's do 1 million. I believe that's it. So we should see that go through. As you see, it took about 1 second to produce a transaction because I had to resolve some things. So this address right here is actually token 33. So let's wait for a confirmation. It looks like I got a confirmation up here. Nexus API, token / get, type equals token, name equals token 333. There you go. Max supply, current supply. So this is actually how easy it was to create a token. I now have a token, identifier 333. That could be correlated to whatever ticker symbol that you want. Generally, that's going to be enforced on logical layers. Token identifier 0, as I was saying, is the actual NXS token. So now what we do, we're going to go, actually, let's go to Viz over here. This is me Viz down on this one. I'm going to grab my session. As you can see, some of these have quite a few things in them, but let's see, token / create type equals account session 4, name equals Viz account 333, identifier equals 333. Boom. So now we have this address here. This is the TXID. This is actually the address of my account. So if I want to, I can go Nexus API token / get type equals account, and I type address instead of name, and that's going to give me that account right here, which has an identifier 333, balance of 0. So I can only transfer from one identifier to another. But if I go over here, / get type equals account, name equals Viz account 333, that's going to do the same thing. That allows you address naming systems. So as you see, this is the actual address published on the network, but this is actually what I'm capable of using. So let's see, we got 3 minutes and 33 seconds left. Nice. I'm going to go over here. I'm going to go API token / debit. Now I'm going to say account from equals token 333 account 2. I'm going to say viz token or viz, let's see, account 333 amount. I'm going to say 1,000. I believe that should be it. Let's do that. Oh, missing pin in session. Duh. Okay, pin. So now the pin has to be entered every single time, obviously for security reasons. The session identifier, this specific one allows multiple login accounts, but that's required for, oops, missing recipient account from, oops, sorry guys. This should have been name from, name to, my bad. Okay, so that transaction was sent. Now I go over here. This is my Viz account. I do account/notifications. Username equals Viz. Oops, type username wrong. Now what this is going to do is this is going to give me the actual notifications of things or events that have happened. So this, as you can see, is the actual amount. This is saying to my account that there is a debit that is going to me. Looks like we have less than 1 minute. So let's see if Viz over here can credit it. Let's see. /credit name 2 equals Viz account 333. Oh. TXID equals this amount equals 1,000. Session equals, let's see. I don't know if we'll be able to make this on the time, but we'll find out. It says less than a minute. Pin equals 1, 2, 3, 4. Oops. Shouldn't be typing so fast. There's the TXID. So what's going to happen now is I can go to here, token/get, type equals account, name equals Viz, account 333. Now we're going to wait for this actual debit to clear, which it just cleared right there on that last block, and there's 1,000 tokens in my account, which shows how the debit and crediting mechanism works. And it shows you your ability to start to transfer these tokens to one another and create them and utilize them. Let's see. I think since we show less than a minute, I think this is probably a good concluding point. We'll show some more features as far as assets and tokenized assets and split royalties payments next week. And we'll kind of give a little bit more. We'll probably have it so that we can show a little bit more time, but I figure this is probably a good time to conclude showing it.
Yeah, okay, 3 seconds.